Nathaniel, and today we will now do question 11 of step 2, 2021. So the continuous random variable has this probability density function. So this, if you graph it, it's good to remember the shapes of graphs. It will look a bit like this with a big maximum point here. So y is actually a discrete random variable, meaning that you just basically have discrete stuff. So show that for any non-integer and py equals to n is the integration of lambda e negative lambda x from n to n plus 1, and then you get minus e negative lambda x n plus 1 n equals to e negative lambda n minus e negative lambda n plus 1 equals to 1 minus e negative lambda n. There, we are done. So show this. Basically, we have to sum a geometric series from this py equals to n all the way up to infinity. So we have the sigma 1 minus e lambda z e negative lambda r, because that's basically the bit we chopped off, equals to 1 minus e negative lambda z over 1 minus e lambda by the infinite geometric progression. Now you realize z is the fractional part of x. That's it. That's what it is. So ez 10 z lambda e negative lambda z over 1 minus e negative lambda dz equals to 1 over 1 minus e negative lambda z minus z e negative lambda z 10, that's the integration by parts, plus 10 e negative lambda z dz. And then you have 1 over 1 minus e negative lambda minus e negative lambda minus e negative lambda plus 1 over lambda. And there we have proved it. Now about the graph, there is this maximum point, and it's because of xe, x having this maximum point, and we can find the maximum point using calculus. And one way to guarantee there's a maximum point, the one thing I remember is that xe to the power of x has a minimum point. So you take the negative of that, it has a maximum point. Well, anyways, see you in another step video.